These notes are going over activity 5.1, and we're going to start by counting atoms in a formula. So you might remember doing this in physical science, but we're just going to review over it today. It's pretty simple and straightforward, but there are just a few rules that you just have to keep in mind. So we're going to review those today. So when reading the molecular formula, it's going to tell you how much of each element are in that molecule. Okay, so for example, if we have H2O, which we know is water, okay, these subscripts, which are the little numbers that are found after the atomic symbol of the element, they tell us how many of that element are in that particular molecule. Okay, so for this example, we have a 2 for hydrogen, so we know that there's going to be 2 hydrogen. Okay, and because there's no subscript here, it is assumed to be 1, so we have 1 oxygen. Okay, so some of the rules, if there is no small number, so like we saw with oxygen, by the element, there is only 1 of that element. Okay, otherwise the subscript, like we saw here with hydrogen, the 2, tells us how many of that particular element is in the molecule. If the formula contains parentheses, okay, whenever we have like our polyatomic ions that we had where we had to put parentheses around the chemical formula, we need to multiply the subscript outside of the parentheses by each of the subscripts inside the parentheses. So the key thing is to multiply each of them. So you kind of do like the distributive property that you learned in math class in order to calculate how many of each of the elements are in the molecule. So let's practice. Okay, so here we have a compound. Okay, and we have potassium, we have sulfur, and we have oxygen. So that's the first thing you kind of want to do is you want to identify what elements are part of that compound or molecule. Okay, so I wrote out each of the ones that I have. I have potassium, I have sulfur, and I have oxygen. So there are no parentheses, so I don't have to multiply in this case. So I'm just going to be looking at the subscripts for each. So potassium has 2, so I would put that there are 2. Sulfur has no subscript, so it is assumed to be 1. And then for oxygen, there are 4. It has a subscript of 4, so there would be 4. Okay, and then this is kind of the compound drawn out for you, and so you can kind of check your answer here. We calculated there was 2 potassium, 4 oxygen, and 1 sulfur. Right, for this next one, it's a bit harder just because there are parentheses. So first I'm going to go through and identify what elements are part of this compound. So I have Ca, which is calcium. I have N for nitrogen, and O for oxygen. So I listed out each of those. Okay. I'm going to start with calcium. There is no subscript, and it is not part of the parentheses. So because it's not part of the parentheses, I'm not going to multiply. I'm just going to take whatever subscript is given, and that's how many of that particular element is in this compound. So because there's no subscript, it's going to be 1. So there's 1 calcium. Right? Now, nitrogen and oxygen are both inside of the parentheses. Okay? So I'm going to have to take the subscript outside of the parentheses and multiply it by each of the subscripts inside. Okay, so remember it's like the distributive property. So 2 times my 1, because I know that this would be a 1, would be 2. So I have 2 nitrogens, and then 2 times 3 is going to give me 6 oxygens. Okay, and we could count this as well. This chapter is about moles, and so you might have heard the term mole before utilized in chemistry. If not, this is an introduction where we're going to go over and review it. But moles kind of help us count things that are super, super small. Okay, so if we had a jar of marbles and you had to figure out how many were in the jar without counting them individually. So let's say that the lid of the jar is screwed on and glued shut. Okay, so we can't open it and just count out the individual marbles. But what we could do is calculate the number if we knew the mass of one single marble, and all the marbles have the same mass, and then we knew the mass of all the marbles combined in the jar. So if we knew that one marble had a mass of 14 grams, and then all the marbles in the jar had a mass of 560 grams, we could take the total amount divided by a single marble mass to find that there would be 40 marbles in the jar. Okay, so moles work in the same way. It helps us to identify how many particles are in a given substance. Okay, and there's other terms. So mole is just representative of a number or a quantity. So we use these quantities, or we have names or terms for other quantities as well. So if someone says pair, you know that they're talking about two. So if I say I have 10 pairs of shoes, I have 20 individual shoes. Okay, a left and a right makes my pair. If I have a dozen of something, you know it's 12. Okay, so if I said that I had 2 dozen eggs, you would know you would take 12 times 2, and that would give you 24 individual eggs. Okay, so the term mole is just representative of 6.022 times 10 to the 23rd atoms. Okay, so that's the amount of atoms in a mole. So whenever we're converting from moles to the number of particles, we're going to use this ratio. And then inversely, if we're going from particles to moles, we're going to use this ratio. So if I have 3 moles of water, how many water molecules do I have? Okay, so I write out I have 3 moles of water, H2O. Okay, and the key thing is you want whatever we're starting with, you want the same unit on the bottom of your ratio. Okay, so like here I have moles, and then I have moles on the bottom. Here I have molecules, I have molecules on the bottom. So you always want, and it's so during math class, or like during going through the math, they would cancel each other out so that we're left with only moles as our unit. Okay, so back to this problem. We're starting with 3 moles of water. Okay, we're going to use our ratio because we're trying to get to particles from moles, so we're going to use this ratio. So 6.022 times 10 to the 23rd divided by 1 mole. Okay, and this is what we get. So I want to show you how to use the calculator in order to solve this, just because some people are not as familiar with using the scientific notation on their calculator. I am going to use like an Apple calculator, and so if you have an iPhone, you can, if you get to your calculator on your iPhone and you hold your phone so that it's horizontal, it will expand out into this, what you see here, and then you can follow along with me. Or if you have a scientific calculator, you'll have the same button function. It's just going to look a little bit different than this format here. Okay, so I have 3 moles. Okay, so 3 times, and then I'm going to multiply across. So 3 times the 6.022 times 10 to the 23rd. So I have 3, that one's pretty easy to put in, times my 6.022, and then to do the times 10 to the 23rd, I'm going to hit this EE button, okay, and then I'm going to put in what I'm raising the 10 to, so 23. Okay, so this right here, 6.022E23, is the same thing as 6.022 times 10 to the 23rd. Okay, so then I'm going to hit equal, so it multiplied it by 3, and so this is my answer. If I check it with this, it's the same, okay, because remember the E stands for times 10, and then this would be the superscript, this upper number that we're taking it to the power of, okay? All right, for the next one, it says if we have 3.613 times 10 to the 24th water molecules, okay, so we're starting with molecules, how many moles of water do we have? Okay, so I'm not using particles, but molecules and particles are interchangeable. Okay, so if I have 3.613 times 10 to the 24th molecules, I'm going to have molecules at the bottom, so I'm using this ratio. Put that in here. So on my calculator, I'm going to be dividing 3.613 times 10 to the 24th divided by my 6.022 times 10 to the 23rd. Because if I would have multiplied this together, it would have just gave me the same, so then I just have to divide. So let me clear out my calculator. So 3.613 and then times 10 to the 24th divided by my 6.022 and then times 10 to the 23rd power, hit equals, and then I get 6 whenever I round it up, which is what we got on this problem. Okay. If you're having issues with using the scientific calculator, let me know and I can kind of help you and walk you through putting it into your calculator. Just let me know, just email me. We're going to do some practice problems with converting between molecules and moles and molecules. So for the first one, how many acetylmorphin molecules would be in 6 moles of acetylmorphin? So first I'm going to start by writing out what we're starting with. So I have 6 moles of acetylmorphin, and I'm just going to put an A just to shorten it. And then I always like to kind of set it up this way where I put it over 1 so I know that it's in the numerator and not the denominator. Okay, and then remember whatever we're starting with, we want that to be in the denominator of our ratio. So we're going to have 1 mole on the bottom, and then our ratio is, again, if looking back at the previous one, was 6.022 times 10 to the 23rd. Okay, and that would be molecules of acetylmorphin. Okay, so then whenever I get my calculator out and calculate this, I would do 6 times my ratio, which is 6.022. Then I hit that EE button to do the times 10 to the 23rd, and I get 3.6132 E to the 24th. Okay, so 3.61 times 10, and I believe it was 24th, yep, to the 24th. Okay, on your guys' homework, on the Google form, you will keep it in the E format. So you would write out 3.61, and you could have kept all of the numbers there, or you could have rounded to 2 decimal places. I generally just like to round to 2 decimal places. And then it would be a lowercase e and then 24. So you can write exactly what was in your calculator, the 3.6123 E24 on your homework, and that would be perfectly fine. Okay, for the next one, a sample of codeine has 12.044 times 10 to the 23rd codeine molecules. How many moles is this? So start out by writing the number of molecules that we have, okay, of our molecules of codeine. I'm just going to put C. Okay, so whatever we're starting with on top, so we're starting with molecules on top, so we're going to have the molecules on the bottom, so 6.022 times 10 to the 23rd molecules of codeine to 1 mole of codeine. Okay, so we're going to be dividing, so if we multiply across, right, 12.044 times 10 to the 23rd times 1 will just give me still that 12.044 times 10 to the 23rd. Same thing with the bottom, I'm multiplying by 1, so then I will divide the 12.044 times 10 to the 23rd by the 6.022 times 10 to the 23rd. Okay, so let me clear 12.044 times 10, which is that EE to the 23rd, divided by our 6.022 times 10, which is that EE to the 23rd, and we will get 2. Okay, so for that one, I just have 2 moles. Okay, and then this one was molecules. I didn't put the molecules. of the acetaminophen. Okay, so there would be units on the homework. You don't have to put in the units because I will kind of like have a blank and then the name of the unit, so you don't have to include that in your homework. Okay, so the key things for your homework, just make sure whenever you're doing the formatting, you are putting it in this way, okay, with the lowercase e. You don't have to try to write out this times 10 to the 24th, okay? You're just doing the 3.61 lowercase e to the 24th or whatever your answer might be for your homework.